Okay, so what we're dealing with here is complex fractions. And what we're talking about here is like a fraction within another fraction. Like if you notice here, there are fractions within fractions, making it very complex. So it's actually not that bad. We know how to deal with this. It's not something that we can't do. We know that there are things on top and there are things on bottom, and that's exactly how we're going to look at this, is that there's things on top we have to deal with and things on bottom. But we're going to end up with fractions over fractions. So when we have a fraction, mathematically speaking, what does that tell me to do at some point? What does this bar tell me I'm going to end up doing? Divide. I'm going to divide. So let's start with the top. Because there's stuff to be done on top and bottom, we're actually going to do that first. We're going to do that top and bottom. So let's talk about the top. What can we do with the top?
Make the denominator the same.
Beautiful. Let's get a common denominator. So what would be a common denominator for 7/12 and 1/6?
12.
Okay, so the LCD there is 12, so we get 7/12 minus some amount of 12s. Well, like how do I turn 1/6 into 12ths? Multiply the bottom by 2, the top by 2, we get 2 12ths. So we get here in the top, we get 5 12ths. Are we okay with that? All right, now bottom, we're going to do the same thing. 2 plus 4 ninths, so 2 is kind of like 2 over 1 plus 4 ninths. So let me just do this here, 2 over 1 plus 4 ninths. So what's a common denominator for 2 over 1 and 4 ninths? 9. Okay, so 4 ninths isn't going to change. What is that? Okay, so that's going to become 18 over 9. 18 over 9 becomes 22 ninths. What do you think I'm going to do at this point? I'm going to divide, but let's write that out because it's a little bit easier to see. 5 12ths divided by 22 ninths. Usually if I write it this way, people go, oh, I know what I'm supposed to do now. Keep, change, flip. Exactly. Keep the first one the same. Don't mess with it. 5 12ths. Change this to multiplication and flip this. Now, if you can cross cancel, you might as well do so because it's going to make your numbers smaller. Like I noticed that, bless you, that 9 and 12 share a factor. What factor do they share? 3 goes into 9 3 times. 3 goes into 12 4 times. So right across the top, 3 times 5 is 15, and 4 times 22 is 88. 15 88ths. No, they're not going to have a common factor there. So the only things I could think of is like, I know 5 doesn't go into it. I know that 15 doesn't go into it. 1 will, but that doesn't help me. So the question is, would 3? And 3 won't go into it either. Yes, ma'am. Michelle.
I did it a different way.
Did you end up with the same answer?
I didn't finish because I just wanted to write what you had.
Oh, did you just multiply straight across the top?
No, I did like on each side. I took the denominator and then multiplied it by the denominator.
I'm kind of confused.
I explained it.
So what we want to do is the top has to be worked separate from the bottom. We have to do the top and bottom.
I did that.
You did that. So did you get, were you here?
Times 6 times 12 times 12. You get it?
So did you get, are you here? Are you right here?
I didn't finish.
Oh, well you did the exact same thing. You're just behind. That's all. You did the same thing as us. Yes, ma'am.
How did you get the 88?
4 times 22.
Okay. And up there, where it says 2 over 12, why is there a 2?
Because 1/6, to subtract things, they have to have a common denominator. So to subtract 7 12ths minus 1/6, you need a common denominator. So we had to change 1/6 into 2 12ths. That's no different than what you did like in elementary school when you subtracted fractions. Same thing. Like if you look at just the top, that's like what you've done 250 million times. Riley, did you have a question too?
Yeah, it was about that. Like, how did you get this?
Okay, so if it's about fractions and how to subtract fractions, then come see me after school because that's actually, we have to go back pretty far for that. So let's do that one afterward. And that's cool. I'll work with you guys after school on that one. All right, but you'll probably pick it up as we go. Let's look at number 2. So we're going to do the same thing here, is that we've got the top where we've got 1/2 plus 1/3. What am I going to do? Okay, we need a common denominator. So what is that common denominator? What's that least common denominator? 6. So they're both going to be something with a 6. Well, let's turn 1/2 into something with a 6th. Okay, so multiply the top and bottom by 3. And then what about 1/3? What does that become? Okay, so in the top we've got 5/6. What about the denominator?
6/6.
Okay, so we've got 6/6 minus 1/6, which becomes... Okay, wait.
Wait,
It's the same thing as
equals 1.
Yes, exactly. So we could sit here and keep change flip all you want, but when you have the same thing in the numerator as you do in the denominator, that equals 1. So you will get the same thing if you keep change flip, but it'll take you much longer than the rest of us who just realize that when the numerator and the denominator are exactly the same, that equals 1.
Because it's the same thing divided by the same thing.
Exactly. Something divided by itself, so it's going to be 1. All right.
Wait.
Wait, that was it?
Would you like me to make it harder? We could...
Well, what if you still have to make the denominators the same, and then you'll still get 5/6, but then you have to keep change flip, so then you get...
Okay, so look, I mean, worst case scenario, if I keep the, look, if I do it this way, so I'll just show you the long way. But we get keep, change, flip. Notice the 6 cancels with the 6, the 5 cancels with the 5, leaving just 1. So you can do it the longer way if you feel uncomfortable, but it'll still work out the same way.
Mr. High, how did you get the 6? And you help, like, for the denominator?
Okay, so let's come after school because we're talking about how to add fractions there. So that's actually not what we're doing today. We're talking about something further back. You need a common denominator. So like, I don't mind. Come after school and we'll work on that, okay? Because that's like something different. Or you might pick it up as we go. I just don't want to spend too much time on that. We'll never get through even the first part of the lesson, and I'm hoping to get through both parts today. So let's talk about 1 minus 4/5. How do I make these? I need a common denominator or I can't subtract them. 5/5 is the same thing as 1 minus 4/5. So right there we've got 1/5. What about the bottom?
20.
Okay, so the number that both of these go into is 20. So we need equivalent fractions. So 1/4 is equal to how many 20ths?
5.
Okay, good. And 1/5 is equal to how many 20ths? 4. So we get 1/20. Now what am I going to do with that? What? I'm sorry, what am I going to do with this right here?
Oh, to keep changing.
Write it down so we can...
Good. Let's just write it so we can see it as division. And then keep change flip. So this one isn't too bad, right? Like this is not so bad. 5 goes into 5 once. 5 goes into 20 4 times. So what is my final answer? 4. 4 over 1, which becomes 4.
Because the 1 over 1 doesn't even count.
1 over 1 becomes 1. Yeah, that 1 over there, if you look at the top, 1 times 4 is 4. Bottom 1 times 1 is 1. 4 over 1 is 4. All right, somebody else talk me through this. I'm just going to sit back and relax on this one. Matthew, you want this one?
Alright, so first, you want to take 2 over 3 multiplied times 2, so you need 4/6.
Okay, so we need a common denominator. Let's be like clear as what we're doing here. We're looking for a common denominator, and both 3 and 6 go into 6.
So we put 4 on top of the first one,
Okay?
5 on the second one, 8 times 1, and then we'll go down for the other part.
Sorry, I couldn't hear. Everyone's too loud in the hallway. Say it one more time. What am I doing?
No, then I did the bottom part.
Okay, cool. I just didn't hear.
So we take 3 times 3 to get 9, so it'll be 3 over 9, plus 2 over 9, there's no point changing that. So then it becomes negative 1/6 over 5 over 9. Then we just divide them, give
Please assist Sabrina Saldivar to student services.
She's on her way.
Thank you.
Have a good afternoon. Okay, keep change flip. Negative 1/6 times 9 over 5. Do we already know whether the answer is going to be positive or negative?
Yes.
We already know it's going to be what?
Negative.
So let's just write that right now so that we don't get confused with that negative in there. We already know the answer is going to be negative, so that we can go, okay, let's just deal with that right now. It's a negative times a positive. This answer is definitely going to be negative. Talk to me now.
Alright, since 9 and 6 are both and 3 can go into both of them, turn 6 to a 2, 9 to a 3, then multiply it across all the bottom.
Okay, so what do we get?
Negative 3/10.
Negative 3/10. That's why I like to deal with the negative right away. A negative times a positive. I don't need to worry about the numbers and which one gets negative. The answer is negative. Negative 3/10. So far, so good? Okay, let's take a look at number 1 down here. Now, this one has got a fraction in it, but it doesn't change anything other than it feels more complicated. I agree that it looks like it's like, wait, there's a variable in there. What do I do? We're still going to do everything exactly the same. We're going to try to get one fraction on top and one fraction on bottom, but now we need a common denominator. Let's agree that z is the same thing as z over 1, and 1 is the same thing as 1 over 1. Now it should be easy to get a common denominator. You guys have done this before. This is what you guys did on the last test to get a common denominator. So what would be a common denominator for the top? Z. But how am I going to make that? Like, I already see that this one is okay over here. 1 minus z is okay. Or sorry, minus 1 over z. But what about the left-hand side? What do I need to do to that? Yeah, it's going to need a z on the bottom, and I have to multiply the top by z as well. So I'm going to get z squared over z. That's a z, not a 2. Sorry. Let me just put my lines in there so it separates them from 2's. Okay, because to make these things have the same denominator, I needed to multiply the left-hand side by z in the denominator and z in the numerator. We get z squared minus 1 over z. That's our numerator. Let's talk about the denominator. The top one? Yes, and we're going to, but I'm going to show you why you might want to wait a step to do it. It's going to look a little complicated if you don't wait. You're totally right, and we're going there on the next step. Let's talk about the denominator. Okay, multiply the top and bottom by z, and we get z over z. So z minus 1 over z. Those are z's. Let me just put my lines there so we don't look like 2's. Okay, so z minus 1 over z. Now what? Well, let's write it out as division. We know it's division, right? We know this. Because usually when you just write it out as what it is, it kind of becomes obvious as to what we're supposed to do. What did we do last time we got to the step? Keep, change, flip. So we're going to keep the first one the same. Z squared minus 1 over z times z over z minus 1. Now, Gabby, you were on to something earlier. Talk to me about what you told me earlier.
To simplify the first fraction.
Yeah, that top is going to become what?
1 over z. Oh, I would subtract the exponent. That's what I would do.
Well, we can't subtract that. We've got two things being multiplied, but this will break down up top into what? That's the difference of two squares. So we know how to do that one. And we still have a z in the denominator. And then we have a z in the numerator. And we have a z minus 1 in the denominator. Talk to me about that. This cancels with that. What else cancels? Z and z. Leaving my answer is just z plus 1. Clean up my z there. It's a little bit of a mess. Okay, I'll give everyone a second to catch up, and then we'll go on to number 2.
So it's just z plus 1.
Just z plus 1. Everything else canceled out. Now, if you notice in the directions there, it says assume all expressions are defined. What that means is that we don't care about where it's undefined. They're saying disregard that there are places where this is going to be undefined. They're not asking that. They're saying just assume that all the answers that we're talking about here are defined. And we're like, okay, that just means ignore the denominator. Okay, let's do that same thing with this. Now notice there's not much difference here. So let's talk about what we've got going on. Are there any fractions in the top? No, so we don't really need to mess with that too much there. So if you feel like you want it as a fraction, we can put it as a fraction in a minute. But let's talk about the denominator, because the denominator looks like the interesting part. That's the one that involves some work there. Do what? Okay, so this right here, that 1 over 1, needs both the top and bottom multiplied by x. Why? Because we need a common denominator of x. So we get x over x plus 1 over x, which then becomes x minus 1 on top. And in the bottom, we get x plus 1 over x. A fraction within a fraction. This is where it becomes is like, oh, this stinks. Okay, so let's just write out what we've got going on here. X minus 1 divided by x plus 1 over x. Well, this almost looks like two fractions that are being divided, except for it's not. Can I make it two fractions?
Yes.
How?
Putting x minus 1 over 1.
Okay, let's do that, because now we can stick with the same thing that we've always done here. We've got two fractions and we're dividing them. Talk to me about that.
Keep,
Keep,
change, flip.
change, flip.
The x plus 1's cancel. Minus 1.
X plus 1 cancels with x minus 1?
Oh, no, sorry, it has to be plus.
Could the 1 and the x cancel?
Well, they're not the same thing, so they can't cancel out.
Wouldn't the x count as 1?
No, because it's not the same thing. So unless they are like obviously the exact same thing, don't cancel them out. So let's look at what we've got. We've got x times x minus 1 over 1 times x plus 1. Do I have anything the same on top and bottom? No, but maybe something happens when I do this math right here. Let's just see. I go, let me just check. X squared minus x over x plus 1. Are the top and bottom the same? No, there's nothing more to be done with this. That's it. Either way, here where it was factored, it didn't help me out. And here where it's worked out, didn't help me out. So, what?
We are left with there.
Well, if there's still more math to do, you should do it. And here there is still more math to do. The reason that we factor it is because things might cancel out and become smaller. But once we've realized that there's nothing else that cancels out, let's work out anything we can. If things can be added together, let's add them. If things can be multiplied together, let's multiply them.
So it would be wrong if you did it solid.
Well, I would say that this is not really finished there. It's got one more step. The top can be worked out. That's this right there. That's what I have as the answer. You and I have the same thing written.
Oh, you circled the other one.
No, she said why? She said, would it be wrong if I answered this? And I circled it. I said this was not finished. That's why I circled it.
Why wouldn't this be the answer?
Okay. Again, no different. Let's talk our way through this.
So 4x would be the denominator.
Okay, so we need 4x as a denominator because one of them has an x and one of them has a 4. So what do I do about that? Okay, so this dude needs a 4 and the other one needs a what? An x. This side's missing the x. So what we're going to get there is that the first fraction is going to become 8 over 4x plus x squared over 4x. Combine those together and we get 8 plus x squared. Sorry? Yeah, we can write it first. That's actually a great way to do it. Since we're going to move it to standard form, let's just do it right there. I was going to do it as an extra step, but let's do it right there. He was just saying let's write the x squared first there, which is totally okay. The order in which we add things does not matter. And on the bottom, we've got x plus 1 over x. There's nothing to be done there. It's just x plus 1 over x. Okay, so now what? Because now it looks like kind of a hot mess there. Let's write it out. This is the same thing as x plus 8 over 4x divided by x over x plus 1. Did I flip it? I'm sorry. I didn't mean to. My brain is jumping ahead. You're right. I should not flip it yet. Thank you for catching that. So we're going to keep the first thing the same. We're going to change the division into multiplication, and then we are going to flip this one right there. All right, anything cancel?
8 and 1.
So remember, these are the only way you can cancel them are if they are things being multiplied. So 8 and 1 aren't going to cancel out with each other. We've got to have, those are things being added together, so we can look at them as like one thing right here. If those two things cancel out together, great. If not, then we can't cancel them out.
Would the x cancel out?
The x will cancel out. Here's an x, here's an x, it's gone. Which puts us to this part here, which gives us x squared plus 8. And then we get 4 times x plus 1. Now, there's still math to be done there, yeah? Like we agree, there's somewhere that you can still do some math? Where can we still do math? On the denominator. So let's just get that done. 4x plus 4. Because having it factored didn't help us out. And this top didn't factor. The top is not difference of two squares, so it didn't help us out. So let's just work out any math that we can. Yes, ma'am?
So I did a totally different thing there. So,
Did you end up here?
no.
Okay.
So, what I first did is I did x squared plus 8, and then I put it in, did x plus 4 and x plus 4.
Nope, that's not how it breaks down.
No?
That's not the difference of two squares. That's why it got messed up.
Oh, okay.
It is the sum of two things, and one of them is not even a square, so we can't use that method there. Can I leave it there, is that what you're saying?
Yes.
Yep. You can only cancel things out. She's asking about that 8 and 4. Why can't I cancel that 8 and 4 out there? One's an 8, one's a 4. Because there are not things being multiplied, and only things being multiplied can be canceled out like that. When you cancel something in the top and bottom, either they're all by themselves with nothing else, or they are things being multiplied. That's when you can cancel them, not when they're being added or subtracted. All right, let's try 4. Now, I noticed something up there. I do, from the very beginning, there's a difference of squares that stands out for me. So let's remember that. At some point, we might be using that. But what should I do first? Let's just write it out as division, because there's nothing, no fractions to be combined here. We've got x squared minus 1 divided by x over x minus 1. We're going to. But the thing is that if you cancel it now, it's hard to see like top and bottom. So let's do our keep change flip and then get it all set up. Let's get it set up where it's ready to cancel. Because we can only cancel there when we know like there's one thing on top, one thing on bottom, or if we're looking at multiplication. So I'm just going to get it in its easiest form here. So let's keep this the same. Change this and flip that. Now I'm going to do exactly what you said. So what did you just tell me to do? Okay, so that x squared minus 1 is the difference of squares. It becomes x plus 1, x minus 1, times x minus 1 over x. Now remember, anything in the top can be canceled with anything in the bottom. So which thing should I cancel? X minus 1. So what is my final answer? Good. 1 over x, not just x. That x is in the denominator. You can't pretend it wasn't there. It was in the denominator. It was not like it just comes out. In the numerator is different. That just is like a whole number. If it's just the numerator and everything else cancels out, the denominator is a totally different story. That's 1 over x. Okay, so let's go on to 5. We'll do 5 and 6. I don't think we're going to make it through all of this today, so we'll do 5 and 6. And then that should be good for today. Somebody help me out.
So write it out.
Okay. Let's just write it out as a division problem. 6 divided by 3, x minus 3. Keep, change, flip. Now, some of you will probably be noticing something at this point. 3x minus 3 can be factored. So let me get over there. what will 3x minus 3 become?
3x. Why?
Because these both share a common factor of 3, and when we pull that out, we get 3 times x minus 1. All right?
Could you also simplify that 3 into 6?
Yes. So he sees the 3, 6 there. Since they're both being multiplied, he says 3 goes into 3 once, 3 goes into 6 2 times. Why not? Let's do that. What else?
Well, the x minus 1 is not.
X minus 1 is gone. Anything else?
The 2 into 20.
The 2 and the 20. 2 goes into 2 once, 2 goes into 20 10 times. What's my final answer here? 10. Confused about what? No, it's okay. Like, I don't mind. Just tell me which step. I can go back. I just need to know how far to go back to. Okay, so instead of uncrossing it out, try to imagine that here's what, I'm going to just go over what was there before I crossed it out. Okay, so here's what was there before we crossed out. Okay, so the stuff in red, are you okay with that? Like, everything else is what we cancel out. See the x minus 1 on bottom and x minus 1 on top? They're gone. 2 things being factored. Okay, so guys, please. See that there is a 3 and a 6 on the right? 3 goes into 3 once, and 3 goes into 6 2 times. So now we have a 20 on top and a 2 on bottom. That's what we're left with, which just becomes 10. So I'm just canceling anything on top with anything on bottom that can cancel out because all these things are being multiplied at this point. Melanie, you have a question?
I had, and then.
Good. All right, one more and then we'll let you get to the homework.
What was the answer?
Wait, can I take a picture?
Yes.
The answer was 10 and
But it really probably helps way more if you actually write it down yourself. Because I find when people just take pictures of it, it doesn't help them much.
I just don't understand when I'm taking notes. and
Okay.
I'm talking.
Okay, number 6. Talk to me.
Multiplied by 2.
Good. So notice that the numerator there does not have a common denominator. It needs one. And as we said, that the left-hand side, if we were to multiply the top and bottom by 2, then we would have a common denominator of 2x. So we'll get 2 over 2x plus 1 over 2x becomes 3 over 2x. All over x plus 4 over x minus 2. What now?
Can I have a question?
Yeah.
How did you get 3 over 2x? Oh, you just.
2 plus 1.
you write it down in,
What?
Just write it out.
Oh yeah, write it out. Sorry, I thought you were asking me a question. My apologies. So we've got 3 over 2x divided by x plus 4 over x minus 2.
And then you change what?
Keep change flip. 3 over 2x times x minus 2 over x plus 4. All right.
You can't do anything.
Exactly. There's actually nothing cancels here. Like the 3 and the 2 don't share anything. The 3 and the x plus 4, the x and the 2. Like you might be like, well, isn't there an x on top and bottom? Yes, but this doesn't have, it's not just an x. There's something with it. It's an x minus 2. That won't cancel out. Only if it's just an x there. So really what we're going to get,
multiply it across.
we're going to do this. So I'm going to do it in 2 steps here. I know that some of you can do it in less steps, but I'm going to do it showing you exactly what I'm about to do. I'm multiplying across the top. 3x minus 6, and I'm multiplying across the bottom, 2x squared plus 8x. Yes, ma'am?
Okay, so for the 3 over 2x, whatever, the 2 is the bottom, yeah, well, the 2 is not connected with the x.
It's 2 times x. That's what 2x means, 2 times x. Like imagine if I told you what x equals. If I said x is equal to 1, you'd do 2 times 1, right? That's exactly how it works.
So like if there was an x on the top, I could just cancel it out.
If it was only an x, yes. But there's that plus 4 stuck to it. Ryan, you have a question?
Can I ask you a question?
Yeah. We can, but guess what it's going to simplify to?
Oh, the same.
It's going to go right back to here. Actually, both of these will simplify, and it'll just take me a step backwards. So since nothing is going to cancel out, I'm just going to leave my answer right there. Yes, ma'am?
Are we able to do the whole entire homework?
Yes, because there's no negative exponents in there. So yes, her question is, are we able to do the entire homework? I can tell you right now that you're welcome to, because I'll tell you right now that tomorrow I'm going to assign you the second half of it. So if you want to push forward and just do all of it, that's fine. Like, I don't mind. You'll just submit the same assignment for today as you will for tomorrow if it's both done, and it'll be fine. Or you could submit the first half today and the second half tomorrow, whichever you want. But so just so you know what's coming there, it's like tomorrow we are going to go over negative exponents, but I don't think there's any negative exponents in the homework. So we're going to talk about negative exponent. I don't think there's a single negative exponent in the homework, is there? No, so it'll get you all the way through there.